Hi everybody, in this video, let's look at 13.2, probability theory involving equally likely outcome. If you want to calculate the probability of an event, let's say event A, so this is the way how we calculate the probability. NA over NS. What's NA? NA is equal to number of equally likely outcomes of event A. And S is number of outcomes of sample space. Okay, if you feel this one hard to understand, let me give you an example. Let's say if you roll a dice, there are 6 numbers, right? A dice. So 1, 2, 3, 4, 5, 6. There are 6 possibilities. So the NS is actually the number of elements of the sample space. So we have 1, 2, 3, 4, 5, 6. Okay, so let's say we let the event A be event of getting an odd number. Okay, from the sample space we choose how many odd number do we have here? 1, 3, and 5. 1, 3, and 5. So NA, it means that the number of elements for this set. So we have 1, 2, 3. So if I ask you to find the probability of an event A, of the event A to happen, then it will be NA over NS. 3 over 6. So if you simplify this one, you get 1 over 2. This is the answer. Okay, let me try one more. So let's say we have another event, event B, event of getting a multiples of 3. Okay, so we have to choose from here, sample space. So how many multiple of 3 do we have here? We have 3 and 6. 3 and 6. So the NB will be 2, 1, 2. So if I want you to find the probability of event B, then it will be NB over NS. NB is equal to 2. NS is equal to 6. So same thing, if we simplify it, we get 1 over 3. Okay, so now you should be no problem, right, to find the probability of an event. It's very important, before you find the probability of an event, you need to know what are the sample space. You need to list out all the possible outcomes first. Okay, let's look at these questions. A box contains 10 pieces of card numbering 1 to 10. A card is picked randomly from the box. Determine the sample space as of the experiment. Okay, as all the possibility. So since the cards are numbering from 1 to 10, so it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are all the possible outcomes. It is impossible for us to get a number 11, 12, and so on, right? Okay, so this is a sample space. NS is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 possibility over here. Okay, so now we go to B. So for A, the question only asks us to list, does not ask us to calculate the number of elements for the set of S. But it's okay because later we are going to use this one. So I show you how to what is the NS first. Okay, now go to B. Event A and B as follows. So we have 2 events over here. So we need to list this the element for set A and set B. Now we have event A. A prime number is chosen. A prime number. So from here we choose from the sample space. So we have 2, 3, 5, 7. Okay, That's all. Okay, so this all are prime number. So how about B? Factors of 12. Okay, factors of 12. 1 times 12, right? 2 times 6. 3 times 4. Okay, so this is 6. 3 times 4. These are all factors of 12, but you have to be careful. If we do it this way, 1, 2, 3, 4, 6, and 12. This is not correct. Why? Because 12 is not inside the sample space. It's impossible for us to get a number of 12. So this is not correct. We cannot include the 12 over here. So we only have 1, 2, 3, 4, 6. 1, 2, 3, 4, and 6. Okay, so the last part of this question. We want to find the probability of event A to happen and the probability of event B to happen. PA. It will be equal to NA over NS. NA is just means the number of elements of set A. 1, 2, 3, 4. NS, 10. So we simplify this one, we will get 24 over 10, 2 over 5. Okay, how about PB? Probability for event B to happen. NB over NS. NB, we look at set B. 1, 2, 3, 4, 5. So we have 5 elements over here. NS, which is equal to 10. So the final answer will be 1 over 2. Okay, let's try this questions. 12 cards of the same size and number 1 to 12 are put into a bag. If a card is drawn at random, find the probability that the number drawn is a prime number, is a number containing 2 digits, and is a multiple of 4. Okay, let's try part A first. Prime number. Okay, it's very important. We need to know the sample space. So the sample space will be 1 under 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so the NS will be equal to 12. Because we have 12 elements over here. Okay, now we look at A, prime number. So we list out all the prime number first. So how many prime number do we have here? 2, 3, 5, 7, 11. Okay, these are all the prime number, right? So now, if you want to find the probability, NS, all the possibility, 12. And the prime number, we have how many prime number over here? 1, 2, 3, 4, 5. Okay, so the answer will be 5 over 12. Okay, now try part B. A number containing 2 digits. Okay, let me list now all the number that contain 2 digits. So this is only 1 digit, 1 digit. Okay, here 10, you have 1 and 0. 11, you have 1 and 1. 12, you have 1 and 2. So these are the 3 numbers which have 2 digits. 2 digits. So it will be 10, 11, and 12. So now, if you want to calculate the probability, then it will be very easy. Number of elements for sample space, 12. So now we want to find the probability of getting a number containing 2 digits, right? So there are 3 numbers containing 2 digits, 1, 2, 3. So the answer will be 1 over 4 divided by 3 divided by 3. Okay, you can also use your calculator to help you to simplify it. You key in your calculator this fraction, then your calculator will automatically simplify it to this fraction. Okay, we have one more over here, multiple of 4. Same thing, I need to find the multiple of 4 from the sample space first. So we have here 1, 2, 3. 1 times 4 equal to 4, 2 times 4 equal to 8, 3 times 4 equal to 12, 4 times 4 equal to 16, but we don't have 16 over here, so we only have 3 multiple of 4 over here, which are 4, 8, and 12. Okay, so the probability will be NS equal to 12. So here we have how many multiple of 4 over here? 1, 2, 3. Okay, so if you simplify this one, divided by 3, you get 1 over 4. Okay, let's try next questions. Okay, let's look at this one. Determine the sample space for each of the following experiment. But this time, this one a little bit different because a number values with the number 1, 3, 5 is found for twice, 2 times. So in this case, I will suggest you, there are a few methods to help us to list out all the sample space. Okay, so first is using a table. You just draw a table first. Okay, after drawing the table, this is for the first spin, this is for the second spin because we spin it for 2 times. Okay, so the first time if you get 1, second time you get 1, the combination will be 1, 1, 1, 1. So if the first time you get 1, the second time you get 3, then it will be 1, 3. Okay, here will be 1, 5. This one, 3, 1, 3, 1. 3, 3. 3, 5. 5, 1. Oh. 5, 1. 5, 3. 5, 5. So these are, if you use this method, right, you won't miss out. You won't miss out, and you will get all the combination correctly. Okay, so S is equal to 1, 1, and if at 1, 3, we have 1, 5. Okay, so it lists up all of these combinations until 5, 5. So if the questions, in the exam, your teacher asks you to list out, you have to list out every single one. You cannot do like this. Okay, so let me write the parentheses. Okay, so let's say if you want to find the NS, then it will be 9. Okay, you have 9 combination over here. So a lot of students, they don't like to draw a table because it takes longer time. So you can use another method, tree diagram. So first spin, you can do this way. Let me use another color. First spin. So we might get 1, 3, or 5. We have 3 possibilities, right? So we draw 3 lines like this. 1, 3, and 5. This is the first spin. So now we go to second spin. Same thing, we have 3 possible outcomes, 1, 3, and 5. So 1, 3, and 5. Same thing, 1, 3, and 5. 1, 3, and 5. Okay, so all the possible outcomes I will write over here. One, which means at first spin you get 1, second spin you get 1. So 1, 3, 1, 3, 1, 5, 1, 5. Okay, and so on. You will still get exactly the same answer, 9 combinations. But you will notice that this takes a lot of space, right? So we have another method, which is this. First spin, you have 3 possible outcome, right? 3 possibility, 1, 3, and 5. You draw 3 vertical line. 1, 2, 3. Okay, And second time you spin it, you also have 3 possibility. Draw 3 line, but this time horizontal, 3 horizontal line. Okay, so this is for the first spin, and this is for the second spin. Okay, so we have 1, we have 3, we have 5. Second spin also the same thing, 1, 3, and 5. Now, to get all the combination, we just look at the intersection point over here. We have 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5, 5, 1, 5, 3, 5, 5. Okay, so you notice that this just use a little bit space, right? Okay, so these are the few ways to help you to get all the combinations. Okay, let's try one more last question. So same thing, if the teachers ask you to list out all the sample space, right? You cannot just draw this diagram. This diagram just help you. You have to list out like this. List out every single combination. Okay, I forgot to discuss the part B. Okay, let me go back to part B first. A coin is tossed and sorry, not tossed, should be pronounced as toss, right? A coin is tossed and a dice is rolled. Okay, now we have a coin and we have a dice. So let's focus on coin. How many possibilities are there? You either get head or tails, right? 2 possibility. Okay, so we draw 2 line, 2 vertical line. One is for head and then one is for tails. So when we roll a dice, there are 6 possibility, 1 until 6. So we draw 6 line, but this time horizontally. 1, 2, 3, 4, 5. Okay, add one more line over here. 6. Okay. Now this is for coin, head or tails, and this is for the dice. 1, 2, 3, 4, 5, 6. Okay, so if I want to list out the sample space, then it will be very easy. Head 1. For the coin, you get head, and the dice you get 1. Head 2. Head 3. Okay, I have listed all the combinations. How many combinations we have here? 1, 2, 3, 4, 5, 6. Okay, 12, right? So it's actually, if you want to get the number of elements for sample space, very easy. Here you have 2 possibility. Here you have 6 possibility. You just take 2 times 6, then you get the answer, which is equal to 12. We can calculate here. So it should be 12 combination. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, 6 plus 6, you will get 12. Okay, let's try the last questions. Letters from the word set and a digit from the number 1, 2, 3, 4 are chosen at random. Find the probability of getting a vowel and an even number. Okay, let me list now the sample space first. The letters from the word, a letter from the word. So we have 3 letters over here. So I will draw 3 vertical lines. 1, 2, 3 for S, E, and T. And then a digit from the number 1, 2, 3, 4. We have 4 digits over here. So I will draw 4 horizontal lines. 1, 2, 3, 4. So if you don't want to use this method, you can use a table or use a tree diagram. So I think this method is very convenient and it will not use up a lot of space. Okay, for letters we have S, E, and T. Now we go to the digit. We have 1, 2, 3, 4. So if you want to list out the combinations, all the possible combination, there should be how many combinations? Here we have 3 possibility. Here you have 4. 3 times 4, that will be 12. So if you want to list out Okay, then it will be S1, S2. We just look at the intersection point. S3, S4. Okay, and so on. Okay, now, how about let me list out all first. Okay, so now we have 12. Total, we have 12 combinations. Okay, now we want to get a vowel and an even number. You can choose from here. So it's actually very easy, very convenient. We can just get from this diagram. We want a vowel, right? So we look at vowel here, E, and even number. So this combination is not okay, right? E and 1. 1 is not even number. So this is a combination that we want. E and 2. Vowel, even number. So E and 3, no. This is vowel, but 3 is an odd number. So another combination we want is E and 4. Vowel, even number. So the probability will be total we have an S is 12, and then here we have 2. So if we simplify it, you will get 1 over 6. This is the answer for these questions. Okay, for this video I stop here first. Thanks for watching and see you next time. Bye bye.